If you're interested in working in data centers, building automation and controls, this video is for you. So my name's Tim Hobbs. I've been working in controls for 5 years, data center controls for 3 years. And so one of the core responsibilities you're going to have to deal with is troubleshooting issues between the field equipment and your PLC, or your field equipment and your SCADA platform. And so the most common thing you may see is someone may hit you up on Teams or Slack, or you may get a ticket assigned to you that says, hey, this piece of equipment is not communicating. So there's so many layers to this, and I'm not just going to talk to you about it. I got this fancy new smart board that I can have like a digital whiteboard now, so I can actually draw out some of these examples, make it more visual. So we're going to walk through an issue I remember I had to solve in my first data center controls in your job. We were having on our SCADA no communications to CRAH number 15 and this particular data hall at our data center 1. So let's walk through it together. We're going to make this interactive, so I'm going to draw out what I think are the pertinent notes for troubleshooting this issue. So we have CRAH 15, which is a computer room air handler, and so I'm going to start off with drawing what the SCADA graphic may look like in your BMS software. So usually the way I'm used to seeing is we have a box, a graphic, right, that shows different data points associated with the CRAH in question. And so if you don't know what a CRAH is, that's a great thing to learn about. You can read about or use AI to learn about what CRAHs are used in a data center, the purpose. But you see here I have a supply air box and I have XXX, which means I have no value in it. So this is the value of the air after the air is cooled off. The supply air is what's being supplied back into the space, which should be your cooler air. Then you have return temp air. That's a box showing what that value would be, and that's the air coming into the top of the CRAH if it's a downflow CRAH coming back from the IT loads. And then we have, for example, a set point that you could be writing to this CRAH. And so in this case we're using Modbus TCP. So that's what the graphic will look like, and this could be any BMS software. A popular one that I'm seeing in the data center space right now is Ignition. That seems to be like the SCADA of choice right now, or BMS software of choice. So, you know, if you love it or hate it, that just seems to be the most common one. When I started in data center controls, I used Wonderware and Aviva, which was pretty interesting. But anyway, so this CRAH 15 had this IP address 10.221.58.30. So this was the IP over the network. So for this particular CRAH. And so if you know anything about networking, for IP version 4, you have the IP address, then you have a subnet mask, then you have a default gateway. So when you get into data center controls, especially for building automation for data centers, you really have to have a good idea of what these values mean, because you're going to be using them all the time. So your subnet basically if you have a gigantic network, the subnet will segment the devices in like a little subnetwork, a little partial section of it. And then your default gateway is how you can get out of that subnet segregated area of your network and get back to the big network. That's kind of the purpose of a gateway. And your virtual LAN, so your VLAN, you may hear it as, the important part of that is that it helps you with routing. So when you have a network switch like I'm drawing right here, you can logically separate the switch into different sections, logical segmentations. And so maybe you're saying, if it's a 48 port switch, maybe you're saying, you know, ports 1 through 16 or VLAN 160, and then ports 17 through 32 or 33 are a different VLAN. So you can set it up that way. But what I'm used to at my first company was that every single port had its own VLAN configuration. So I thought that was interesting. But anyway, so for your building automation controls networks, you're going to have a network switch for your controls network. And so as you can see, I'm using port 1. That's what I labeled it. That particular port of this switch is connected to my CRAH device in the field. More specifically, it's connected to the communication module in CRAH 15. So this is going to be an Ethernet cable. You may hear people say, hey, check the Cat 6 or check the Cat 5. What they're talking about is a certain category of Ethernet cables, like a standard, right? So you have different levels, like Cat 5, Cat 6, Cat 6A, and these are just different. That's for telecom stuff. But basically, you have Ethernet cable going to your comm module here. So this is how the SCADA system, which is going to be installed on a virtual machine as in your infrastructure, it's going to be on the big network. It needs to be able to reach the IP address of 10.221.58.3. The way it does that is your network switches are also on the big network, and so the network switch gives the SCADA a way to reach this field device. So the SCADA node can reach the switch, and then the traffic gets routed through port 1, and then it goes into an Ethernet cable and to the comm module. That's how I'm able to reach 10.221.58.3 to pull data into my SCADA system. And the industrial protocol we're using is Modbus TCP. This is super important. So if you want to work in data center controls automation, you have to understand industrial protocols like Modbus especially, and BACnet, I would say SNMP for sure, and OPC UA is a big one. But so I'm using Modbus TCP, which means my communication is happening over an Ethernet cable. If I was using Modbus RTU, it would be different. It'd be over a serial cable, RS-45 twisted pair shielded cable. So in this case, on my CRAH comm module, I had to double check and make sure, was Modbus TCP enabled? Was I using port 502, which is the default Modbus application port? And my unit ID was set to 1. So this is important because my SCADA system needs to make sure I'm pulling the IP address and trying to reach it over Modbus at port 502 and ID 1. So the troubleshooting steps. First thing you want to do is, can I ping the IP address? So in this case, I could not ping the IP address. So I was like, okay, that's a problem, which means the SCADA is trying to get it to it over the network switch through the Ethernet cable to the device, but there's a break somewhere in there. Okay, is it a switch issue? So I cross-reference. I had a document called a port schedule. You may hear it as port mapping. You may hear it as switch config, which basically I can know all these devices connected on this switch. It's a 48 port switch, and I'm seeing all the other devices we're communicating, so it's isolated to this particular port 1. So I'm like, okay, so not a bad switch. And now my VLAN could be wrong. If my VLAN is not set to 160, the traffic's not going to be routed correctly across the network. I'm going to get no communication. So that could be an issue. Or I could have a bad Ethernet cable. So if my Ethernet cable is bad, then I'm never going to be able to reach the CRAH IP address because the Ethernet cable is there, so the path isn't there. So that's something else to consider. This is a good time to talk about like a tool called a link runner. So I didn't know what a link runner was until my data center controls job, and it's a tool basically you can use to test Ethernet cables, and you can see where what switch the Ethernet cables terminate to. It tells you all the information, so it's pretty cool. I use them quite a bit, especially for the older data centers, because you don't know when something was patched, if it ever was patched, or if it ever was checked that it was patched in the right spot. So link runner will tell me what's going on. So it'll tell me, hey, what switch am I connected to? Do I have the right VLAN? Is it on the network? It'll tell me some good stuff there. If I plug the Cat 6 cable at the CRAH into my link runner, it should be able to tell me that network switch's name. It should say port 1, and then it should say VLAN 160. That is what I am expecting to see. So when this issue, once I get to this point, once I can't ping a device, I pretty much just get out of my chair and I go walk to the device and figure out what's going on, because there's nothing I'm going to be able to figure out if I can't ping it. And if I try to ask my network team, they're going to ask me the same questions. They're going to ask me, did you check the layer 1 issue? So I might as well just save the time and just go walk out there. So I walk over to this unit. I wish I still had the picture on my phone. So I go out there and I'm like, okay, what I'm expecting to see is an amber light and a green light on the Cat6 cable, Ethernet cable, plugged into the CRAH 15 communication module, showing they have good connection. So I walk over there, and I do see a amber light, which means it is terminated on both ends. So if I see an amber light at CRAH 15's communication module on that Ethernet cable, I'm like, okay, so it is connected back to a network switch. But I double check myself, and I grab my link runner and I plug the termination at the CRAH 15, and I plug it into my link runner, and it says the network switch name, and it says port 1, and it says, what else does it say? It gives me the port number, it gives me the blade, switch blade if I had that, and then it said VLAN 1. So that's a problem. So as the traffic's trying to get routed across the network switch, in the network switch, the virtual LAN 1 is a default VLAN. It's not used for any routing, which means every time the data was trying to be routed through this network switch, it just couldn't go anywhere. It couldn't get back to the SCADA. And so, which means I couldn't ping that IP address. So what I had to do was take a picture of that on my link runner, and then I contact my network team and say, hey, on this switch port, port 1, here's the IP address, here's the subnet mask, here's the default gateway. The virtual LAN should be VLAN 160, not VLAN 1. So then they do their magic, they log into the switch over an SSH session, and then they change it to port 160, and then within like 5 minutes, my communications come back. I get my supplier temp, my return temp, I see my set points coming back in, I see all the other points that I'm monitoring come back. And so building controls automation, this is a rather simple problem, but it's heavily involved. You have networking, you have SCADA, you have a network switch, right? So networking, you have the physical device itself, you have the industrial protocol configuration. Like if something's wrong with the Modbus TCP configuration, that would be a problem. If I have the wrong IP address in there, that's going to be a problem. And so I will tell you, a lot of problems you can solve in your data center building automation and controls career is just by getting out of your chair and walking to the unit and figuring out what's going on. This will save you so much time, and having the tools you need, like a link runner, for example, that'll save you so much time. And so, yep, but that's all I got for you guys today. I hope this new format's a little bit better, a little more interactive, and so until next time.